Great. Hi, everyone. So this is a much better video, isn't it? It's not made with my phone. Anyway, so what I want to do here is talk through some of the answers on the practice exam. So in particular, I'm going to do the syllogisms and the truth tables. Now, how do I stop this? All right. So we're just going to start in the beginning because that's a really good place to start with the syllogisms, right? So for this, you need to do a couple things, right? First, I'm going to give you a mood and a figure. In this case, it's EII4, right? And you need to give me a categorical syllogism that has that form, or that mood and figure, rather. And then you need to diagram it, right? And tell me whether or not it's valid or invalid on the basis of the diagram. So all of these ones are from the Boolean perspective, so that's all we're going to do here. So why don't we start by getting an instance of EII4. So we'll start with the first premise, type E, right? So that means it is nil blank are blank. But what do we put in the blanks? Note that the figure is 4, right? So the middle term is going to be in the predicate position of the first premise and in the subject position of the second. Right? And the predicate will be up here, and the subject will be down here. Okay, so this is our first premise, no P or M. Our second premise is going to be of type I, which means it's going to start with some M, R, S. Right? So far we've done this much. E, I, and we've got our figure. Now we have our conclusion, which is denoted by this last I. It's going to be the same form as this, sum S, R, P. Okay, so this is the first thing you need to do with this one, right? You need to reconstruct a syllogism that has this mood and figure, right? And this is what we get, no P or M, some M or S, so some S or P. Now the question is whether or not this is valid, right? So we're going to come over here and we're going to diagram it. I've already set this up. Remember that the circle on top is M, lower left-hand corner is S, lower right-hand corner is P, right? And I've labeled these as well, 1, 2, 3, 4, 5, 6, 7. Hopefully that shows up on the video. Okay, so how do we diagram this? Right, the important thing is that note that we have a universal and a particular premise. When we have that, we need to diagram the universal premise first, right, and then the particular one. So we're going to start with the first premise in this case. And we want to diagram no P or M. So what we want to show is that of all the things that are P, right, none of them are M's. Right? So these would be the things that are in the P circle, right? And the things that are in 3 and 4, right, these would be things that are both P and M, right, because that's where the P circle and the M circle overlap. So remembering that shading means that there's nothing there, right, what are we going to shade? So think about it for a second. Hopefully you said 3 and 4, right? We want to shade 3, right, to show that there's nothing that's both P and M, right there. And we also want to shade 4, right, because those would be things that are both P and M as well, right? And we're told that there are none of those things. Okay, now we can diagram the second premise. We're told that some M or S. So what does that mean? Well, that means we're going to have to put an X, right, because it's particular. And we're going to have to put an X in a place where something is both S and M. Right? So this is what's remaining of the S circle that's unshaded, 2, 5, and 6. And the question is, where do we put the X? First question, do we put it in 6? Well, this would be something that's S, right? But it's not something that's M, right? So we don't put it there. What about just here in 5? Well, these would be things that are merely S, right? And we're told that there's something that's M and S, right? So not in 5. So that leaves us with 2. Is that where something that's M would be S? Well, note that the S circle and the M circle overlap, right, in 2, and it's unshaded. So if there's anything that's M and S, right? It's going to be here. So we can put an X there. Okay, so we've diagrammed our premises, right? And now we want to go to the conclusion. And the question is the conclusion depicted or reflected in this diagram? So what's our conclusion? Some S are P. So we look at this diagram, right, and we ask ourselves, is it the case that according to this diagram, some S are P? So what we're going to be looking for is an X, right? We want to see if there's an X here. And it needs to be in a particular place, right? It needs to be in the place where the S's are the P's. So that would be in 6, right? Because this is where the S and the P overlap. So the question is there an X there? Quick look at the diagram suggests not, right? So it turns out that this is invalid. Right? Because the conclusion isn't reflected in the diagram. All right. So our next one, this is number 2, has the mood and figure IAA2. So same thing again. We're going to give an instance, right, and then we're going to diagram it to see if it's valid. So let's start off. So first thing to note, perhaps, is that the figure is 2, right, which means that the middle term is going to be here in the predicate position, right, of both of the premises. Okay. Of course, our predicate goes here, and our subject goes here, right? The predicate goes here because, again, it's the major term, the predicate of the conclusion, right? And the major term goes first, or major premise goes first, minor premise goes second, and then the conclusion. The minor premise is the minor premise because it has the minor term, right? The minor term being the subject of the conclusion. Okay, so we have sort of the frame here. Let's put everything else in as well. So first premise is a type I, which means it is, think about this for a second, I'll write it up. Some P or M, I hope you got that. Second premise is of type A, which means, well, I'll write it up what you think about it. Which means it's this, all S are M, right? Again, I hope you got that. And then finally, our conclusion is of type A. At this point, you should know what it is. It's all S are P. Right? So this is our categorical syllogism. Some P are M, all S are M. So our conclusion, all S are P. Okay, so now we want to diagram this. Again, one of our premises is particular and the other is universal. Right? So we want to diagram the universal one first. So remember, whenever you have a universal premise and a particular premise, always diagram the universal one first. Right? If they're both particular, it doesn't matter which order you do. If they're both universal, it doesn't matter. But if they're mixed, right, you have to do the universal one first. Okay, so we're going to diagram our second premise here first. So all S are M. Right? So what we want to do, right, is shade this to show that all of the S's are among the M's. Right? So what we want to do is shade any part of the S circle, right, that doesn't overlap the M circle. So what would that be? Would we shade 2? No, because it overlaps, it's part of the S circle and it overlaps the M. Same with 3. What about 5? Well, these are things that are merely S, right? But we're told that all of the S's are M. So there can't be anything in 5. So we'll shade that. Okay. What about 6? Well, this is part of the S circle, but note that it doesn't overlap the M circle, right? It only overlaps the P circle, and we're told that all the S's are M's, right? So if there were anything in 6, it'd be an S but not an M, so we need to shade 6. Okay. So we finished the second premise. Let's move to the first, some P or M. So since it's particular, we're going to have to put an X on here. The question is, where do we put it? Well, we want to put it in a way that shows that there's something that's both P and M. Right, so the question is, where do we put it? Well, if it were in 3, that'd be something that's P and M, right? Because it's in the P circle, and it's also overlapping the M circle. So do we put it in 3? Think about it for a second. Well, it turns out the answer is no. Hopefully you got that. If not, I'll explain to you why. Think about section 4. If that object were there, right, it would be both P and M as well, right? But these are different possibilities, right? If it's here, then it's P and M, right, but it's not S. Right? But if it's here, it's P, M, and S, right? But this is consistent with either of those possibilities, right? So since the X could go here, right, or it could go here, we're going to put it on the line in between. Does that make sense? I hope. We'll do more examples like this. Okay, so anyway, we've diagrammed our premises, right? And now we want to know if the argument's valid. So again, what we're going to do is we're going to look at this conclusion, right, and ask, is it the case, according to this diagram, that the conclusion is true? Right? If it's not, then the premises can be true and the conclusion false at the same time, so the argument's invalid. So we can ask ourselves, is it the case, according to this diagram, that all the S's are P's? Well, no, right? Note that this part of the S circle, 2, is unshaded, right? And since this is unshaded, right, it means that there are some things that are S and M, right? Or it's consistent, rather, with there being some things that are S and M, right? But that's inconsistent with the conclusion, right? So according to this diagram, the conclusion is possibly false, right? And since the conclusion is possibly false according to this, it means that the premises can be true while the conclusion is false, right? Which just means that the argument's invalid. All right. All right. So here's the third one. We want a categorical syllogism with the following mood and figure, AAO3, right? So let's do the same thing we have been doing. We'll put little slots here for the subject, predicate, and middle term. All right, so what is the figure 3 saying? Well, it says that the middle term goes here in the subject position of both the premise, or both premises, both the first premise and the second premise, or the major premise and the minor premise. And we know that in the first premise of a categorical syllogism, the predicate of the conclusion appears, and in the second, the subject of the conclusion appears. Okay, so we have sort of our frame now. And now we can go in and put in more information. So the first premise is of type A, which means what? I'll write it up while you think about it. Okay, it means this. All M are P. Second premise, same idea, right? It's also of type A, so it's going to be the same thing. All blank, in this case M, are blank, in this case S. Okay, so first and second premise are done. That was quick. Now we can do the conclusion, and it's of type O, right? So what does that mean? Well, think to yourself while I write it up here. Right, it means this, some S are not P. Okay, so here's our syllogism. Now we want to diagram it, right? Again, to see if it's valid or invalid. So note that both of our premises here are universal, so it doesn't matter which one we do first. Let's just do the first premise first. So all M are P. So we want to shade this diagram to show that there's nothing that's an M that's not a P. Right, so that means we need to shade the parts of the M circle, right, that don't overlap the P circle. So that would be 1. And anything else? 2, right? Because this is part of the M circle, but it doesn't overlap the P circle. All right. So we've done the first premise, all M are P. How about this second one? All the M's are S. Right, so again, we're going to be working with the M circle, right? And we want to shade in such a way as to show that there is nothing that's an M that's not an S. Right, so we want to shade any part of the M circle, right, that doesn't overlap the S circle. Right, so we've already shaded 1 and 2, right, so we don't need to do anything there. You could, I guess, shade again if you wanted. What about 3? Well, 3 overlaps both M in S, right? But we're told that all the m's are S, so we don't do anything with 3. What about 4? Well, this is part of the M circle, and it overlaps the P circle, but it doesn't overlap the S circle, right? What this says is that there's nothing that's here, right? There's nothing that's an M and also an F. Or sorry, there's nothing that's an M that's not an S, right? If there were something in 4, right, that would be something that's an M but not an S, right? So we shade here. Okay. So now we've diagrammed the premises, right? There's nothing else left to do, right? So we ask, is the conclusion true according to this? Well, from the Boolean perspective, it's really easy to say, no, of course not, right? What we'd want to do is look to see if there's an X, right? Because this is a particular conclusion, right? So to be reflected in this diagram, right, it would have to be the case if there's an X here, but there's not, right? So that's sort of a shortcut, I guess. But barring that, right, let's sort of think about why the conclusion is false according to this. We're told that some S are not P, right? What we would need, right, is some X, right, in the S circle that doesn't overlap the P circle. Would that be in 3? No, right, because this is S and P. They overlap there. Similarly for 6, right, it means that there would have to be an X somewhere in section 5, right, but there isn't, right? So from the Boolean perspective, this is invalid. All right, so now we have our fourth one, right? And this is a categorical syllogism with the mood and figure A, E, O, 3. Right, so again, we're going to give an instance diagram, see if it's valid or invalid. So we can put S and P down here, right? Subject of the conclusion, predicate of the conclusion. Let's do the figure now. It's 3. That means that the middle term, denoted by M, right, is in the subject position of both the first and the second premise. Okay, and then we'll put P here, right, because it's the major term, and the major term is the non-middle term, denoted by M, right, that goes in the first premise. We'll put S here. Okay, so now we can go through and put in more information. So first premise is of type A, right? So think about what that means while I write it up. Right, so it means that all M are P in this case. The next one is of type E, right? So what does that mean? Again, think about it while I write it up. Here is what you should have, no M or S, right? This is the type E categorical proposition. And then finally, we have our conclusion. It's a type O. Think about what that means while I write it up. Right, so here we have some S or not P. It's maybe an odd time to mention this, but if you don't know what a type A or type E or type O categorical proposition is, you should contact me. This is something that you should know by now. Otherwise, this is probably just all being gibberish, and that would be a shame. So anyway, here's our categorical syllogism. All M are P, no M are S, so some S are not P. So now we want to diagram this. These are both universal, right? So it doesn't matter which one we do, right? We'll just start with the first one. All M are P, right? So we want to shade the parts of the M circle that don't overlap the P circle, right? To show that all of the M's are among the P's. So what do you think that's going to be? Well, we're going to shade 1, right? Oh, that was horrible. Sorry, I hope that didn't come through. So we'll shade the first one, right, to show that there's nothing that's merely an M, right? If there is anything that's an M, according to the first premise, it has to be a P as well. And then we'll shade 2, right? Because although this is an M, it's not a P. Okay. What about 3? Well, this would be something that's an M and a P, right? So we don't shade there, and similarly for 4. Okay. Second premise, no M or S. Actually, it occurs to me that we should have been doing AEO4 rather than AEO3. But this is just additional practice, so we'll keep going. Sorry about that. You have to roll with the punches sometimes. Second premise, no M or S. What we want to do is shade to show that nothing that's an M is not an S. Right? So we're going to have to shade in 4. Okay, because these are things that would be M, but not. Sorry. Not in 4. Importantly, do you see why shading 4 was the wrong thing to do? We can use this as a learning moment. Shading here in 4, right, would mean that there's nothing that's both an M and a P and not an S, right? But we want to show that none of the M's are S's, right? No M is an S, which means that we need to shade where M and S overlap, right? Which would be 3. Right, so we should have shaded 3, not 4. So I hope that makes sense. Okay, finally we have our conclusion, some S are not P. Is that true according to this diagram? Well, again, right from the Boolean perspective, we know that it's not because there's no X. Good, but where would an X go? Some S are not P. Well, we'd want to mark in a place where something is an S and not a P. That's unshaded, which means it would have to be in 5. Right? It couldn't be in 6, right? Because that's both an S and a P. Right? And the only other part of the S circle that remains unshaded is 5. Right? Since there's no X here, right? It turns out that this argument AEO3, which is not, it turns out, the 4th one I asked you to do, is invalid. But we're in a pretty good position to do the 4th one very quickly. So bear with me for just one moment. AEO4. Actually, I've erased more than I needed to. Do you see why? So first premise of type A, all P are M. Second premise of type E, no M are S. And then finally our conclusion, some S are not P. Okay. So the reason I didn't have to erase as much as I did is that all of these propositions are of the same type, right, as the last ones. All that's changed is the figure. So the only difference between this syllogism and the last one is that P and M are switched in the first premise. Okay, so let's diagram this extremely quickly. So all P are M. We want to shade the parts of the P circle that don't overlap the M circle, right? So what is that going to be? Well, it's going to be 6 and 7, right? These are the parts of the S circle, or the P circle rather, that don't overlap the M circle. So shade 6 and 7. Right. Second premise, no M or S. So we want to shade the parts of the M circle that overlap the S circle. So what would those be? 2 and 3, right? So we'll shade those. Okay, good. So now we can look at the conclusion. Is it true, according to this diagram, that some S are not P? Well, again, no, there's no X, right? And we're doing the Boolean perspective here. So we know that it's invalid, but if we wanted to see why it's invalid, we would ask ourselves, well, where would the x go? As before, the x would go here, right? But there's no x on the diagram. So this one is invalid from the Boolean perspective. Right? And again, this is the one we were supposed to have done. All right, so now we're on our finally, categorical syllogism from the practice exam. And this one is of mood and figure AIA3. Right, so since the figure's 3, we know that the M is going to be in the subject position of both the first and the second premise. We can put an S down here, a P down here, P up here, and an S down here. Again, we know that the P goes up here in the first premise because that's the major premise and that has the major term, which is P, the predicate of the conclusion. We know the S goes here, right, because the second premise is the minor premise. It has the minor term, where the minor term is the subject of the conclusion. Okay, cool. So let's fill in the rest. So first premise is of type A, which by now we should all know is this, all M are P. Second premise is of type I, right, which is particular. So it's going to start with some M, R, S. And then finally our conclusion is universal of type A. So it starts with all S, R, P. Okay, good. So I hope you got this at home, all you wonderful people out there in the dark. Sorry, if you've not seen Sunset Boulevard, that meant nothing to you. But you should see Sunset Boulevard. It's really good. Okay, anyway. So here we go. We want to diagram this now. Note that we have a universal premise and a particular premise. Again, the rule is if we have a mixed type like this, we need to start with the universal one and then do the particular one. So we're going to start with the universal one per the rule. So all M are P. We're going to do some shading here, and we're going to shade what? Well, we're told that all the M's are the P's, or all M's are P, rather. So we want to shade any part of the M circle that doesn't overlap the P circle, right, to show that there's nothing there. So which parts of the M circle don't overlap the P circle? So here's the M circle, here's the P circle. Well, 1 and 2. 1, 2. Right, so we shade those. The shading's getting harder and harder as the board becomes weighted down with used chalk. But hopefully that shading, okay, it sort of shows up, I think. So we're good. Next premise, and luckily this is the last one that we have to do any shading for. So next premise, we can now do some M or S, right? So this is particular, so we're going to put an X someplace, and the question is where. So what we want to do is show that there's something that is an M, it is also an S, right? So it's going to be somewhere, right, in the M circle where it overlaps the S circle. So where does the M circle overlap the S circle? Well, it does it here in 2 and in 3, right, and nowhere else, right? But 2 is shaded, so it can't be there, right, which means that the only other place it could be is here in 3. So we'll put an X here in 3. So here's one of the cases, right, where the X doesn't go on the line. Okay. So we've diagrammed our first premise, we've diagrammed the second. Now we want to know whether or not the conclusion is true according to the diagram. Is it the case, that is, that all S are P? Well, let's look at this. No, it's not, right? It's really easy to see that it's not true according to the diagram, that all the S's are P's, right? According to this diagram, it's perfectly consistent with everything that's been said, that there are some S's out here, right, in section 5, right? And if they're in section 5, right, they don't overlap the P circle, right? Which would mean that there are S's, right, that aren't P, right? So according to this diagram, it's consistent with the truth of the premises that the conclusion is false, right? And what does that mean? It means that it's invalid. Okay, so those are all of the categorical syllogisms that were on the practice exam, plus a bonus one. Hopefully these made sense. If you have any questions about them, let me know, and we can talk about it. So the next thing we're going to do are the truth tables. All right. So what you have here are some arguments in English, right? And then I want you to symbolize them and then construct a truth table to see whether or not they're valid. So the argument that you had was either it's raining or it's snowing. Right? If it's not raining, then it's snowing. It's not raining, therefore it's snowing. So I'm using R and S for pretty obvious effect, right? R means it's raining, S means it's snowing. Good, and this is how you would symbolize it, rather. So the first premise, either it's raining or it's snowing, R, wedge, S. Second premise, if it's not raining, then it's snowing, so tilde R, horseshoe S, right? The tilde meaning not, right? The horseshoe meaning if then. Third premise, it's not raining, right? So not R. Conclusion, it's snowing. Okay. So here's how we would set up the truth table, right? So we have R and S over here, right? We're going to put true and false under those to give us sort of the information for the rest of it. Here's our first premise, second premise, third premise, conclusion. And I typically do 2 lines, right, to mean that the conclusion comes next. Or if I don't typically do it, I sometimes do it. You don't have to do it. Just make sure that your conclusion comes last. Okay. So how do we set this truth table up? Well, we want to know how many rows it has, right? So it has 2 different sentence letters, R and S, right? And that tells us how many rows we have. So the number of rows in your truth table is this, 2 to the n, where n is the number of different sentence letters. So in this case, it's 2 to the second, right, which of course is 4, right? So we have 4 rows, 1, 2, 3, 4. So we want to set up our truth table like this. True, true, false, false. True, false, true, false. Right? And this ensures that all of the combinations of true and false for R and S are covered. Right? Why is that important? Well, think about what the rows represent. Right? They represent different ways that the world could be. Right? And what we're trying to figure out, again, is whether or not the argument's valid. Right? And the argument's valid just in case, right, or if and only if, it's not possible for the premises to be true and the conclusion false at the same time. Right? So if we left out one of the rows, right, we'd be leaving out one of the possibilities, and that might be the possibility that shows that this is invalid. Right? So it's really, really, really important that we have all of the possibilities covered. Okay, so we're just going to go through this pretty quickly. So first premise, R or S. Right? So how do we figure that out? Well, we use the information over here, right, and what we know about the wedge. So we know that the wedge, a sentence with the wedge, rather, where it's the main connective, is true, just in case at least one of the disjuncts is true. Right? So think about the first case, where they're both true. Right? We can ask, is at least one true in that case? Well, yes, they're both true, so this is true. Second case. R is true and S is false. Is it true? Yes. Let's make those maybe a little more legible. Second case, or third case, rather. R is false and S is true. Is this true? Well, at least one is true, so it's true. Final case, they're both false. Is this true then? No, it's false, right? Because it's true just in case at least one of the disjuncts is true, and here they're both false. So false there. Next case. So what I would recommend doing here is filling in under the tilde, right, the not. Right? So what would not R be in this case? Well, the tilde changes from true to false and from false to true. So in this case, if R is true, right, it's going to be false here. So false, same idea on the second line. Third line, it's false, so it's going to become true. And same on the last one. And then for S, we have just taking information from over there. True, false, true, false. Okay, now we're going to combine this information to figure out what the truth value of the whole thing is. Right? So the horseshoe is true just in case it's not the case that the antecedent, in this case R, is true, and the consequent, in this case S, is false. Right? That is, here's the table for the horseshoe. Right? So just so long, right, as it's not the case that the antecedent is true and the consequent is false, it's true, right? So when they're both true, it's true. When the antecedent is false, right, either in the third or the fourth case, it's true. It's only in the second case where the antecedent is true and the consequent is false that the horseshoe is false, right? So what about this first case where our antecedent is false and our consequent is true? Well, we can look down here into our third line and we see that it's true. Okay, second, where they're both false. Again, we can look down to the fourth line this time. True. Okay, third one where they're both true. Well, we look to our first line. They're both true. Or it's true, rather. And then finally, the last line where the antecedent is true and the consequent is false. This is false, right? That's the one case, right, where it's false. Okay, over here. Again, it's going to be false, false, true, true, right? And again, we're just taking the information from over there and putting the not sort of in front of it, right? So this is false because it's true over here, and it has a not in front of it, and the not changes the true to the false and the false to the true. Okay, finally, we have our conclusion, and that's just taking the information from over there. True, false, true, false. Okay, so question, right? Is this argument valid or invalid? Right, so remember that the argument's invalid, right, just in case it's not valid, right? When is the argument valid, right? That's just in case it's not possible for the premises to be true and the conclusion false at the same time. So what we're looking for, right, is a case where all of the premises are true, right, and the conclusion is false at that row. Right, so is the first row like that? Well, true, true, false, right? So not like that, right? Because here it's not the case that all the premises are true, right? And we need that. What about this case? True, true, false. Nope. True, true, true. Okay. But true, right? So this isn't a case where the premises are true and the conclusion false at the same time. So we're good. And then here we have false, false, true, false, right? So there's no row here, right, where all the premises are true at the same time and the conclusion false, right? So that means that the argument is what? Valid. All right, so here's the next one. I've done more of the setup this time simply to save a little bit of time. So this has 3 sentence letters, B, R, and S, which means that there are 8 rows. Again, because the number of rows is given by 2 to the n, where n here is 3, so 2 to the third is 2 times 2 is 4, right, times 2 is 8. So 8 rows, and we set it up like this: true, 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 false, 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 true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. Okay. And here's our argument. If S, then B. If R, then not B. Not B, therefore R. Okay. So I'm going to do a sort of truncated version here. Let's set up our conclusion first. So we're just going to take the information from over there and transfer it over here, trying to keep them on a line, or lined up. This is why, incidentally, I prefer to do these on a ruled paper, but whatever. Okay, So we should have true, true, false, false, true, true, false, false. Okay, so remember what we're looking for, right? We're looking for rows where all the premises are true and the conclusion is false at the same time. So sort of think about what that means. Any row where the conclusion is true is sort of irrelevant for our purposes, right? We don't have to do anything. It's just not important. So I propose that we sort of cut our work in half, right? We don't do this first row. Right? We don't do this second row. We don't do this fifth row. We don't do this sixth row. Right? And that leaves the third, fourth, seventh, and eighth rows to do. But again, those are the only ones that are relevant, right? Because we're looking for rows where the premises are true and the conclusion is false. Right? These rows that end with T, right, in the conclusion, they don't tell us anything about whether or not the argument is valid or invalid. They're, again, completely irrelevant. So let's cut our work in half. Let's just do these ones. Okay. So let's start, say, with this row. True, false, true. Or, sorry, let's start with this column, if S then B. So we're going to use the information over here to solve this. So in this case, the antecedent is true, right? And the consequent is true, right? So the whole thing is true. In this case, the antecedent is false, the consequent is true, so the whole thing is true. Right? Down here, we have a true antecedent and a false consequent, right? So this is the one case, right, where this is false. Right? And then we have false antecedent, false consequent, true. Okay. Now let's sort of think about what we know. Right? Again, we're looking for a row where all the premises are true, right, and the conclusion is false at the same time. So if we get to this point and there's a false premise, right, we don't need to worry about it. So we can get rid of this one. Right? Again, because we're looking for rows where all the premises are true and the conclusion is false at the same time. But here the premise is false. So that one is irrelevant. So now we've even cut our work down more. We only have these three. Okay. I propose we do not B next. So here, not B, it's true over there, so it's going to be false here. It's going to be false here. And then finally, this last row, it's going to be true. Okay, so again, we can ignore these rows, right? Because these are rows where not all the premises are true, right? The first premise is true, but the third premise is false. Right, so we can ignore this row and this row right after it. So look how much we've reduced our workload at this point. We only have to figure out this last one. Right? All these other ones are irrelevant, right, to whether or not the argument's valid or invalid. Okay. So here's the last one. Now we have to solve for this. Right? Note that if it's true, right, then the argument's invalid. If it's false, it turns out that the argument's valid, right? Because there'd be no row, right, where all the premises are true and the conclusion is false at the same time. Okay, so let's figure this out. So what we have is a false antecedent, and our consequent is B, which is false, right? But then it becomes true because of the tilde. Okay, but what do we know about the horseshoe or the if-then? Well, it turns out that if the antecedent, the first part, is false, right, the whole thing is true. Right? So what we're left with, there's my eraser. What we're left with, you'll note, is a true premise, true premise, true premise, false conclusion. Right? So what does that mean? Well, since an argument is valid, right, if and only if it's not possible for the premises to be true and the conclusion false at the same time, right, it turns out that this argument is invalid. All right, so I want to skip ahead to number 5. I don't think the other ones will really cause any problems, but if people really want me to go through them, I will. But I'm going to skip them right now because it's very late. So anyway, and also I think this last one, number 5, is the most interesting of the bunch. So the argument is that first premise, it's Monday. Second premise, it's not Monday. Conclusion, it's Tuesday. And I've symbolized this like this: M, tilde M, therefore T. Really weird argument. Presumably no one argues, like no one would ever offer you that argument, but it illustrates what I think is a really neat point. So here's our truth table, right? It's going to have 4 rows because there are just 2 sentence letters, M and T. Okay, so let's go through and fill this thing out. It's going to be really easy. So true, true, false, false, right? And we're just drawing from right here, right? Just this information. Okay, over here, right? Now we have not M. So we're just going to flip M, right? So it's going to be false, false, true, true. Okay, and now we have our conclusion. So true, false, true, false. So now we want to know, is the argument valid or invalid? And again, what we're looking for, right, is a row going across, right, where all the premises are true and the conclusion is false at the same time. If there's a row like that, then the argument's invalid. If there isn't, the argument's valid. So let's just go row by row. So first row, is it the case that all the premises are true and the conclusion false at the same time? No, right? The premises aren't both true at the same time, right? So it's not the case that the premises are both true and the conclusion false at the same time. Second row, same idea. It's not the case that they're both true, right? So it's not the case that they're both true and the conclusion false at the same time. Third row, same idea, right? One's false and one's true, right? So it's not the case that the premises are both true and the conclusion false at the same time, right? Which is what's required for invalidity. And then finally, the fourth row, it's not the case, right, that they're both true. One's false and one's true, right? So it's not the case that they're both true and the conclusion false at the same time. Okay, so think back to this argument. It's Monday, it's not Monday, so it's Tuesday. Really weird argument. You might think intuitively not valid, right? But what this truth table shows is that it is valid because there's no row where the premises are true and the conclusion is false at the same time. So one thing we talked about, like in the very beginning of the course, right? If you go through and you look at the sort of written walkthroughs and notes that I provided for you, or if you look at the book or the PowerPoints that you have, it's that validity is kind of cheap, right? It's really easy for an argument to be valid, it turns out. Lots of arguments that you would intuitively think are bad arguments are valid arguments. And this is one of those cases, right? And it's sort of a quirk of the definition, right? The definition tells us that an argument's valid just in case it's not possible for the premises to be true and the conclusion false at the same time. We look at this argument and we see that it's not possible for the premises to be true at the same time as the conclusion is false, right? Why is that? Well, it's because the premises are inconsistent with one another, right? It can't be both the case that M and not M for any M, right? Contradictions aren't true, right? These are contradictory. Because they're contradictory, it turns out, sort of interestingly, that anything follows, right? So this argument is valid. So that's the last one I think I'm going to talk through. Actually, let's do 4. Let's do 4. So sorry for sort of jumping back and forth, but 4 is a neat one. Sorry, I'm gonna, well, maybe not neat, but it's something. Okay. So it's only 2 sentence letters as well. So S, or not S. If not S, then H. If S, then H. Therefore, H. Okay. So one thing to note here, it's either the case that S or not S, right? it doesn't matter what S is. It's either the case that it's raining or it's not raining. It's either the case that you're tall or you're not tall. It's either the case that it's Tuesday or it's not Tuesday. Doesn't matter what S is. This first thing is always true. Now look at the second and the third premises. Right? One of them says that if not S, then H. The second one says, or the third one rather, says that if S, then H. Right? So the sort of idea here is that no matter how the world is, right, whether it's S or not S, and it has to be one, right, it's going to be the case that H. So sort of intuitively, we can see that the conclusion H follows. So this would better end up being a valid argument. So let's set it up. So we only need 4 rows, right, because there are only 2 sentence letters, S and H. Oh man, this is chalk. And I'm sort of running out of room, sorry. Okay, this is why I set these up beforehand, because it gets bothersome sometimes. Anyway, so really quickly, we're not going to fill this in excruciating detail because we sort of walked through it, and you can sort of see what's going on. This first premise, S or not S, right, it's going to be true the whole way down. So at least, so here, S is true, right? It's a disjunction. Disjunctions are true if at least one is true, so it's true there. Second one, S is true. Okay, second one, or third one, S is false, but note that it's not S over here, so it becomes true. So this is true, and same idea in the fourth. Okay, so as I said, true all the way down for this first premise, S or not S. Let's look over here. If not S, then H. So not S goes from true to false. So false, false, true, true. H is true, false, true, false. If F, then T is true, right? If F, then F is true. You can check this with your, well, you should have the horseshoe memorized at this point, but you can check with a truth table for it. And remember, the horseshoe is true just in case. It's not the case that the antecedent is true and the consequent false. So this is going to be false here. But here, they're both true, so it's going to be true. Here we have just, it turns out, the horseshoe truth table. So first row where they're both true is true. Second row where the antecedent S is true and the consequent H is false. This is false, true, true, and then we have H. True, false, true, false. Okay, cool. So is this argument valid or invalid? Well, here's the relevant ones here, getting rid of some of the noise. So is there any row where the premises are true and the conclusion false at the same time? So first premise is true, second premise is true, third premise is true. Oh, conclusion's true, so we're good. Second possibility, true, true, false, false. Well, they're not all true, right? So it doesn't matter what the conclusion is. True, 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 true. Okay. True, false, true, false. Again, not all true, so it doesn't matter. So since there's no row, right, where all the premises are true and the conclusion is false at the same time, this argument's valid, as we sort of informally showed at the beginning. All right, so that's a very long video. That's like an hour now. But that is all of the categorical syllogisms, or those are all of the categorical syllogisms and almost all of the truth tables. Like I said, we didn't do number 3 in the truth tables. If you want me to, I can. Let me know, but it's really just more of the same. But But yeah, so anyway, I hope this was helpful. A little bit different than the sort of videos that we normally do. For one thing, longer. For another thing, maybe the production values are a little bit better. I'm not sure about that. That's maybe going a little bit far. But anyway, these are things that you can sort of work out on your own and then check, right, given the key is now up. So check on the key and then look through here. And if you think I got something wrong, let me know. Anyway, thanks.